Did you know this rocket took more than 10 years, billions of dollars, and thousands of engineers before it ever touched the launch pad? This is the Space Launch System, the Artemis rocket, the most powerful machine NASA has built for deep space in generations. Without this vehicle, the Moon stays distant, Mars stays theoretical, and human exploration remains trapped close to Earth. Every weld matters here, every bolt matters. Every connection decides whether this machine climbs cleanly or tears itself apart. You are about to watch one of the most ambitious manufacturing programs on Earth. Stay. I will show you exactly how. The numbers are brutal, more than $90 billion. Years of redesigns, delays, testing, and a schedule stretched across administrations. And money was never the only problem. Scale was the real enemy. Size magnified every weakness in the system. The fully fueled rocket towers above the Statue of Liberty and weighs millions of pounds before the countdown even begins. At the center stands the core stage, a giant aluminum spine built to store super-cold fuel for launch. It begins in Louisiana, inside Michoud, where enormous sections arrive like raw bones waiting to become a deep space vehicle. Nothing here feels small. The metal panels are massive, the tooling is gigantic, and the tolerances stay painfully tight. Engineers align each curved section with extreme precision, because one tiny error here becomes a major problem later. Then comes friction stir welding, one of the most important manufacturing steps in the entire Artemis assembly process. No melting, no filler. A rotating tool crushes the metal together under pressure and leaves a stronger, cleaner bond. That process creates huge seamless barrels, turning separate aluminum sections into tanks built for violence, vibration, and cryogenic stress. These tanks must hold liquid hydrogen and oxygen at brutal temperatures without cracking, leaking, warping, or failing under load. And this stage is not just a tank, it is the structural backbone of the entire rocket. It carries engines, avionics, plumbing, thermal systems, and launch loads all at once, while staying astonishingly light for its size. Once the structure is ready, attention shifts to the engines, the most proven hardware anywhere on this vehicle. NASA chose 4 RS-25 engines, machines born in the shuttle era and refined through decades of brutal testing. Each engine is a masterpiece of turbo machinery, forcing propellant through the system at insane speed, pressure, and heat. Workers lower those engines into place carefully because this stage demands precision, not drama, at every single connection point. Fuel lines, sensors, control systems, brackets, and interfaces all have to align inside a tight mechanical maze. There is no room for improvisation here. Every connection is checked, documented, verified, and then checked again. That is the hidden truth of rockets. Speed looks glamorous. Reliability is built through repetition, discipline, and relentless inspection. Once the engines are mounted, the core stage finally starts to look less like hardware and more like destiny. But Artemis still needs raw force, and that force comes from 2 giant solid rocket boosters strapped beside the core. Each booster is enormous, stacked from multiple segments, and packed with propellant powerful enough to shake the ground at ignition. During launch, those boosters deliver most of the rocket's thrust and help rip the full stack off the pad. They are transported, positioned, and assembled at Kennedy Space Center under procedures designed to eliminate even tiny mistakes. This is where logistics becomes mission critical, because Artemis is built across many sites, not under one roof. Major components travel across states, facilities, and teams that must perform like one machine under one timetable. If one component slips, the schedule slips. If one interface changes, dozens of downstream tasks change with it. And while this giant machine comes together, subscribe, like, and comment if you want more mega engineering builds like this. After booster stacking, the core stage is lifted and joined between them with extraordinary care and almost zero margin. Now the rocket starts to feel truly colossal, a vertical machine assembled in layers like a steel cathedral. Then comes Orion, the spacecraft built to carry astronauts around the moon and eventually far beyond it. Orion adds another challenge, combining American hardware with a European service module and extremely unforgiving mission requirements. By this point, Artemis is no longer one product. It is a living network of interlocked subsystems. Navigation, guidance, software, communications, thermal protection, and life support all have to function together without hesitation or delay. And none of those systems matter unless the full stack survives fueling, ignition, ascent, separation, and deep space flight. Before launch day, NASA rehearses everything, because rehearsal is where weak points reveal themselves before disaster does. The assembled rocket rolls toward the pad on the crawler, one of the heaviest vehicles ever built by humans. That trip feels surreal. A machine this tall moves at walking speed while carrying years of effort on its back. At the pad, engineers begin wet dress rehearsals, simulating the full countdown and fueling sequence in painful detail. Cryogenic propellants begin to flow, temperatures collapse, metal contracts, valves cycle, every sensor reading starts to matter more. This is where rockets become brutally honest, because super cold fuel exposes leaks, timing errors, and hidden weaknesses instantly. Artemis faced delays, troubleshooting, hardware issues, and repeated tests before NASA trusted the stack enough to commit. That patience was expensive, but rushing a machine this dangerous would have been even more expensive in every possible way. Then launch day arrives, and every team narrows its focus to one thing: clean ignition and controlled ascent. The countdown moves, final checks clear, tanks stay stable, computers agree, the rocket stands ready at last. Then the engines ignite, building power in sequence as the entire vehicle strains against the hold-down system. A moment later, the boosters light and the launch pad disappears inside fire, smoke, and impossible sound. In seconds, years of manufacturing become raw physics, millions of pounds of thrust forcing the rocket into the sky. This is the payoff: every weld served, every checklist protected, and every delay was trying to preserve. Artemis rises because thousands of invisible industrial decisions, large and small, were correct at the exact same moment. That is the real truth of Artemis. This rocket is not just built, it is coordinated. Steel, software, logistics, chemistry, and politics must align before ascent becomes possible. So the question is no longer whether America can build this. We just watched it happen. But if one launch costs this much, who reaches the moon first?